Hello there, this is exercise 15B for A-Level Maths in Year 12. Now we've seen a bit of this before. This is integration today we're going to look at. Now on exercise 15A we saw a couple of things really. I suppose if I just went through them now it won't hurt. We saw that sometimes we get told what dy by dx is. This is a gradient function. It can also be written as f dash of x. And basically we need to integrate it to get back to the original y function or f of x function. It can be written out in any of these ways. But this process is called integration. Okay, you have to integrate to do that. Sometimes as well it just has this symbol for which means integration. It might just say some integrate, I don't know, 3x to the 4 minus 8 dx. And it's this process. So number one, it can be the backward version of differentiation, if you like, undoing an integration to get back to where you started. And number two is just out and out, it just says integrate. That weird symbol there means integrate. In both cases you end up with this thing called plus c, the constant of integration. Without it, you'll get the answer wrong. So you need to write those. So let's have a look at an example question. Now, since we are playing around with backward differentiation, I thought it best to initially just look at a couple of differentiations. So if it says y, what is dy by dx? And you should remember, you bring the power down to the front. In this case, you times it, the 2 by the 3, you get 6x. And this one is just really, well, it's 1x for a start. It's 1x to the 1. So when I bring that down, I just end up with 1. This one looks a bit more complicated. It's got nasty powers, and that's one of the things we have to be able to deal with. So make sure you're copying all these down. Make sure you're getting these. Again, if there's no number, you assume it's a 1 at the front. Times what that half gives me a half x. And this is where these dodgy powers get tricky. I've got to knock one off a half, and that's to the minus a half. Minus. Well, I've got to bring this 2/3 down to the front, and 2/3 times by 3 is actually 2, but I've also got to be aware that it's a minus and it's a minus, so it's a plus 2 x to the power. Now if I knock 1 off minus 2/3, I actually get minus 5/3 plus 2, a number will just disappear, so that's me done. 2 will disappear. Now, sometimes you get dodgy powers again, so I'm going to rewrite this as a not so dodgy power before I do anything. So the 2 I'm happy with on the bottom, but the x squared I'm going to write as x to the minus 2. So when I do this, dy by dx becomes, I'm differentiating of course, so it goes minus 2, brings down to the front, gives me minus 3x. And I've got to knock off 1 from minus 2, which is minus 3. This one, oh, be careful, I've got to multiply these together. This is x to the 1, and this is like x to the half. So this is 3x to the 1/2, which is better written as 3 over 2. So when I differentiate it, I've got to times 3 by 3 over 2, which is actually 9 over 2. Knock off 1 from that power, gives me, it's 1/2 now, gives me a half. Oh, this one again, I've got to do a division here. I'm going to do this up here. I need a bit more space, I think. So I've got y equals, now it's 3x divided by x cubed. So I can do each part individually. So that gives me 3x to the minus 2. Remember, you subtract the powers. Now 5x cubed divided by x cubed, well that's easy, plus 5. This one is really x to the half, and if I divide it by x cubed, I think I'm going to get like 2x to the 2.5 on the bottom. That's best written as x to the minus 5 over 2. Now I have to differentiate it. Differentiate it means do a bit of multiplication. That's minus 6, and then knock off a power. 5 will disappear. Times that gives me plus 5 over 2 x, and I've got to knock off a power. It's not very nice, but that's what it is. That's interesting. Whoever did this answer here has got that wrong, because it's a differentiation and whoever did it integrated. So anyway, I've got rid of it now. I've said that all along on this. Do I get we others right then, having done that? Half x minus half plus 2x, yeah, 6x. Yeah, so everything else is right. So let's now properly do some integration. We've spent 5 minutes reminding ourselves of differentiation, but now notice this question says dy by dx equals, and it wants the family of curves, so I need a y equals. But one problem I've got here is it doesn't say what I wanted to say. It's got brackets, so I've got to get rid of these brackets before I can do anything. So I'm going to apply these out. I get x squared minus 3x plus 2x. I reckon I get minus x minus 6. That's what I start with. Now remember the rule. I add a power. That's my step 1. Step 2 is I divide by the new power. Divide by the new power. It's important that you remember it's the new power you divide by, and then add a c at the end. 3-step process that we're going to try and do every time. So here, add a power, x cubed, was x squared, x cubed, divide by that new power, minus, this is x to the 1, so add a power, divide by that power, minus 6, well this becomes minus 6x, because it's got no power, so it gains power. Don't forget your plus c. That's it. It was doable as soon as I got rid of the dodgy brackets. And likewise, this is like the differentiation I just did. I've just got to divide each part before I can do anything. So x to the 4 divided by x squared is x squared. Minus a half x cubed divided by x squared is minus a half x. And x squared divided by x squared is plus 1. So now I've got this, I can now find y. X squared, add a power, divide by the power. Minus a half x, well this is x to the 1, so I'm going to do, that becomes x to the 2. Now notice I've got a half, I'm going to divide by the 2, and that's going to make it 2 2s are 4, so I actually get minus a quarter x squared. Plus 1 becomes plus 1x, or just x, plus a constant. I don't know where the answer is going to come. Oh, they came there and there. So, yep, that's all right. And this one, I think that's right as well. So this time, notice it's out and out right integrations this time. It just says integrate. So I'll do the same thing though. My very first job is to rewrite it as a nice power. 4x. It's on the bottom, x cubed. So I'm writing 4x to the minus 3. This I'm going to write as plus a third of x to the minus a half. Notice the third, 1 over 3, stays as a third. But this root x on the bottom, of course, we know root x is to the power of half. But it's on the bottom, so it's minus a half. Minus 7x. And I've got to integrate that with respect to x. So what's that give me? It gives me add a power. So it's minus 2. So it becomes 4x to the minus 2 over minus 2 plus a third x. Now add a power to a minus a half, I get a half. So I've got to divide by a half. How weird is that? A minus 7x, I said. Have I integrated that straight off? I have. That should have just been minus 7. But when I integrate it, it does become minus 7x. Yes, that's now right. So what happens when I do this division? 4 divided by 2 is 2, so this is minus 2x to the minus 2. Now a third divided by a half. You either remember that if you divide by a fraction, you turn up upside down and multiply. Now that interestingly is going to be 2/3. Or you just do it on your calculator. What is a third divided by a half? 2/3, thank you very much. Do it on your calculator if you're not sure. Minus 7x plus a constant. So hopefully, you'll see the answer in a bit, that'll be right. Now what's this say? This says integrate 5x squared times by the cube root of x dx. I don't like that. So this is really 5x squared times by, it doesn't say times, but that's what it means. And it's a cube root, we should know that's x to the third. And the next thing I'll say is when you multiply powers together, you should know you add them. Do 2 plus a third in your calculator, you get 5x to the 7/3. Okay, not pretty, but there we go. That's what we've got to do. So I'm going to integrate it. Add 1. Now 1 is 3/3. So it becomes, really, it's going to become 5x to the 10/3. Divide by that new power, 10/3. Plus a constant, but what is 5 divided by 10/3? Turn upside down and multiply it, gives me 15 over 10. I reckon that's 3 over 2, x to the 10/3. But again, check it on your calculator. So the answers according to me are, that looks right, and the next one, 3 over 2, yes, they're both right. And last two examples I've got, I'm not even sure I've done the answers to these, we'll see. It's, well, I don't like the, it's t for a start, I didn't spot that. It's the integral of 3t to the minus 3 plus effectively a fifth of t to the half minus 1 dt. So when I integrate this, I get, add a power, I get minus 2, so it becomes 3t to the minus 2 over minus 2. Plus a fifth of t, add a power, that's 3 over 2. So I'm going to divide a fifth by 3 over 2 minus t, plus a constant. So I'm just going to tidy this up. This gives me minus 3 over 2 t to the minus 2. What's a fifth divided by 3 over 2? So turn upside down gives me 2, I get 2/15. Is that right? Yes, that sounds reasonable. I think it's 2/15 t to the 3 over 2 minus t plus c. Okay, so I think that's right. Well, I'll check that in a bit. So again, this I don't like because it's got the division. Get rid of the division. You divide it into all three parts. 5y over to the 4 over y cubed sounds like 5y to me. Y cubed over y cubed disappears. That gives me minus 3 plus 9y. This gives plus 9y. I'm divided by y cubed, so minus 2. Okay, at least I've got proper powers now. So if I integrate this, I get 5y squared over 2 minus, add a y to that. Y is an unusual letter to have on these, by the way, but usually it's x, but can be t, can be y, can be anything you like, as long as they're consistent. And it says plus 9y to the minus 2, so that's going to be plus 9y to the minus 1 when I add a power, divided by that minus 1, plus a constant. So if I just tidy that up, that should be 5 over 2y squared minus 3y minus 9y to the minus 1 plus a constant. Let's see what I got. Minus 3 over 2 to the minus plus 2, 3 over 2 minus 2. Yeah, so that works. And this one, we've got 5 over 2y squared minus 3y. Yeah, so that works. Look, that's it. We're just going to practice a few of these. This is exercise 15b. Don't know what's wrong with that. We'll see that in class. But notice, by the way, this is the posh way of writing this. The integral of ax to the n dx is ax to the n plus 1. Notice my power has increased, and I've then divided by the new power. So if you ever look in the textbook, that's probably what you'll see. But for now, thank you.